Let's talk about methods. So methods are just functions inside of a class. Certainly a property is a function inside of a class too, and so is a constructor. But methods are just the general term that we use for functions that are not constructors or properties. Now, most classes will have a method that returns the data from the class as a string. That's because strings are so useful when you're trying to share information between different machines, and also, of course, to present that data to a human. So we might want to make a method that would do that too. In our case, we have this person class, and it's got the first name and last name. And it's got the constructor, and it's got the properties. And I'm going to add a new method. The new method is called toString. And what its job is it returns data in a comma-separated string of values. In other words, I'm going to take the first name and the last name, combine them together with a comma in between. Pretty simple. Once I've done that, I return that data. Now, in this case, what will happen is that when I run it, I'll include Bob and Smith as the input going into the class's constructor. From the constructor, it'll go into the properties. It'll do the validation. And then later on, when I call the toString method from my object, it will combine the first name and last name by reading the data from the property, which you may remember has the formatting of changing the lowercase to uppercase for the first letter, the title casing. So even though I pass in Bob Smith with lowercase, what I get out of the string, the toString method, is the Bob Smith and title casing with a comma in between. And this is a typical pattern. We typically see this. Having a comma-separate string of values is very, very useful because a lot of software expects that to be the case, including, huge amounts of data that you might download about various different scientific topics. Often it'll be presented in this simple comma-separate value form. You could also do another one. I can make a function called like toJSON, in which case I return Java object notation. Let's see, JSON, Java simple object notation. I think that's how it is. Anyway, it's a format where you use something that looks a little bit like a dictionary. In fact, it looks quite a lot like a dictionary. Instead of a comma separate value set of data, you have a JSON set of data. Anyway, there's nothing stopping me from making as many methods as I want, as many that make sense. Right here, though, I'll just stop with this simple one because this is one of the most common ones you'll see. In fact, it's so common that many languages already have one built in. So Python has one. It's called _string_. So it's another one of those dunder functions. The string function, or toString function, does basically the same thing. It takes the data that you have and returns it. However, if you don't change the way it works, if you don't actually write the code yourself, it'll use the invisible one that comes with Python. Now, there's a reason for this, and we're going to talk about that next week when we talk about inheritance. But just know that there is an invisible method that will always be part of your class called _string. And the string method returns the address that of the memory address where the object instance is at. Now, I'm not entirely convinced that's all that useful, but that's what it does by default. Still, you can change that behavior. Let's look at some code. So I've got a very simple class here. It's the demo class. It's got one field in there. I make an object from it, and I call it toString. And when I do, because I didn't do anything to change the way that the demo1 class works, we can see that from that first object, we see the address. So main _main .demo, and main is the main body of the script that we're running out of. So the main body of the script, the main script .demo, demo is the name of the class. The object made from that is at this memory address. You can probably see now why I just use like 123 or 442 or whatever. I just made up something a lot more easy to talk about than using a real address. Now the second class, demo2, is different. I actually define a method, and it's got the same name as that invisible one that's always going to be there. When I do this, it overrides the original to do whatever I want. In this case, what I wanted was to format it with greater than less than symbol and the data in between. And that's what I get. And I'll get that if I take the variable and I convert it to a string. If I go ahead and use the print command and convert it to a string. Guess I could add another one in here. If I just actually go ahead and use print, because if I just use print, it calls the toString function for me. And if I go through and actually call it explicitly by just putting in the double underscore string, double underscore, it all gives me the same thing. So this would give me some data, converting it to a string. If I don't use that, print will actually convert it to a string for me invisibly. And if I want to explicitly call it, I can do it like this, but it doesn't matter. When I print it out, it's going to use my version, my customized version of the string function. Now this happens on all classes that you work with. You can either get the default, or you can choose to make it something different. For example, if I make up a list, the list is a class, and this is actually making an object from that list. I know it doesn't quite look like it, but it automatically does that for you. Another automatic thing. We saw in earlier modules that we could go ahead and use a variable and print out the contents of that list. We also saw that we could use a type function to make sure that it told us that the type was list. Well, list was the name of the class. And that particular class has overridden the default behavior. It doesn't print out the address. Instead, it prints out the content like this: square bracket 1, 2, 3, because that's the data in that list. Now, we know that individually, these can individually be referenced by using data list, square bracket 0 or 1 or 2 to identify the index, the element that you're working with. But that's because it's all programmed into this list class. We don't really look at the list class. We just use it. And it works in a particular way, and so we just keep using it that particular way. One thing that you'll notice that I'm not entirely convinced that the way that they chose to print it out with the toString function was all that great. Basically, they chose to put square brackets here. Not the worst thing in the world, but it was a choice. They could have done something different. In fact, if you want something different, and we have often wanted something different, we just make a loop, go through each one, and reformat it, because we don't want it printing out like this. That was one of the things that we didn't want in our files. And now you know why it actually came back like this when we printed it out, and why we had to do it ourselves, because the way that the people who made the list class wrote their string function, they made a choice. If we don't want to use their choice, we have to write code to do it our way. Not difficult, we just had to make a loop, right? And change the way it was represented. We converted it over to just a comma separate value string. Now, here's an example of that person class we've been working on. I've got the first name, I've got the last name. I have the toString method, and in the toString method, I do that concatenation of the first name and last name. Now, I want the standard string function to work the same way. So what I can do is I can actually go through and just call my customized toString method, and now I have both. They're both linked together, and I kind of prefer that myself. I think that having a method that actually says to_string is more obvious than the double underscore string. But you know what? Other people disagree with me. They think that it's best to always have the one that you know is always going to be there. Preferences. I think to myself, why not just have both? And that's what I've done. Now I have both. You can use one or the other. That is a personal preference, though. And you'll see other instructors who do not agree. In either case, when I make up a new person object, I can use toString. That's my customized one. The string function, which actually uses my customized one, it overrides the original thing of showing only the memory address. And of course, since I'm using print, if I don't specify a method, it'll automatically call the double underscore string method, because the people who wrote the print function put code in there to make it do that. There are lots of different automatic pieces in Python, and there's many automatic methods and invisible methods that come with classes. We're going to talk a little bit more about them in the next module, but for right now, why don't you try modifying the person class that you were working on before to have a toString function, like the one I just showed you, that will send back the name, first name and last name in a comma separate value file. And then also go ahead and override the string function, the built-in one, to use your custom toString function, just like I showed you. Try typing it out if you can. If you can't, you can always copy and paste it. Go ahead and pause the video, and then I'll see you back when you're done. Okay, let's take a look at this. So this is the code all typed out. I'm going to put a breakpoint here, and I'm going to walk through it. I'll right-click and choose Debug. Let's see how it goes. So first step is it passes over Bob Smith into my constructor. I use that in the properties for validation. And since it's not a number, it works just fine. And then moves on to the next one, the last name, and does the same thing. And then when we print it out, it's going to call the string function because I didn't specify anything, and that's what the print function does. It automatically calls the double underscore string function. And I have my double underscore string function linked to my custom one, and so it runs the custom one. And what I get back is using the getter title casing. Actually, it looks like I didn't change the name of the title. I didn't put title casing on the last name, so I'll have to fix that. Of course, I won't be able to see that because I put in capital letters. So during my testing phase, if I would have chosen to use lowercase letters, that would have shown up. And what I would have seen is that the last name should be formatted in title casing. There we go. Run it, check it. Yep. We enter it in lowercase, we check that. Also, we need to check numbers, right? So let's do that. Exactly. I'm not sure this is the best error message ever made, but we've already covered that, and I'm trying to keep the code real simple. So that's how you create a class. That's all the main components that you need to know to get started. There's always more to know, but you'd be surprised how much ground this covers. If you learn how to use constructors, properties, and methods in classes, you've basically come quite a long way. And from there, you've got all the basics down that you can use to start programming, putting classes in your applications. Next thing to talk about is adding some other features to your class that might make it just a little bit better. I'll see you in that video.